Hello, students. Welcome to today's physics class. We're going to cover a very important and fascinating chapter, fluids and properties of matter. This topic isn't just important for your exams. It's something you see all around you. When you pour water into a glass, when an object floats or sinks, or when an airplane flies. Let's break it all down, step by step. Let's begin with density. What is density? It is the mass of a substance per unit volume. In simple words, it tells us how tightly matter is packed in a given space. The formula is density equals mass divided by volume. The SI unit is kilogram per cubic meter, relative density. Now, how do we compare the density of two substances? That's where relative density comes in. It is the ratio of the density of a substance to the density of water at 4 degrees Celsius. It has no unit because it's a pure ratio.
Mim, may I ask a question?
Yes, go ahead.
Why is the reference temperature always 4 degrees Celsius for water?
Excellent question. Water has maximum density at 4 degrees Celsius. That's why we take it as the standard reference point for comparing densities. Pressure in liquids. Think of swimming in a deep pool. As you go deeper, the pressure increases. That's because pressure in a liquid depends on depth. We calculate it using pressure equals height multiplied by density multiplied by gravity. Pascal's law says, pressure applied to a confined liquid is transmitted equally in all directions. That's why hydraulic lifts and brakes work so efficiently. Buoyant force. When you place an object in a liquid, it feels lighter. Why? Because of buoyancy, the upward force exerted by the liquid. This principle states, a body immersed in a fluid experiences an upward force equal to the weight of fluid displaced. This explains why a ship can float despite being heavy. When an object is placed in a fluid, two forces act on it. Its weight, which pulls it downward, and the upthrust, which pushes it upward. If the weight is greater than the upthrust, the object sinks. If the weight is equal to the upthrust, the object floats with its entire volume submerged. If the weight is less than the upthrust, the object floats partially above the surface. Fluids can flow in 3 ways: streamlined, laminar, turbulent. And every fluid has a critical velocity beyond which it becomes turbulent. Reynolds number helps us identify the type of flow. Less than 1,000. Smooth, more than 1,500. Turbulent, between, transitional flow. 1,000, 1,500. This principle is based on mass conservation. For an incompressible fluid, we use area multiplied by velocity equals constant. Energy of flowing fluid. A flowing liquid possesses pressure, energy, kinetic energy, potential energy. Bernoulli's theorem. Bernoulli's equation is pressure plus half rho v squared plus rho gh equals constant. This explains how airplanes lift off. Faster air over the wing reduces pressure.
Mim, may I ask something?
Yes, please ask.
Why does pressure decrease when the velocity increases?
Great observation. In a flowing fluid, if velocity increases, kinetic energy increases. To conserve total energy, pressure energy must reduce. That's Bernoulli's principle in action. Torricelli's theorem. This theorem says velocity of efflux equals root of 2gh. This is why water spurts faster from the bottom of a tank. Viscosity. Viscosity is internal friction within a fluid. It resists motion. Honey has high viscosity, while water has low. Stokes' law. A spherical object moving through a viscous fluid experiences a retarding force. Formula 6 multiply pi multiply eta multiply r multiply v. Terminal velocity. When a falling object stops accelerating and moves at a constant speed, that's terminal velocity. Poiseuille's formula. It calculates flow through narrow tubes, more pressure and larger radius, thus higher flow. More viscosity or length, thus slower flow. Intermolecular forces. 2 types. Cohesive, between like molecules. adhesive, between different molecules.
Ma'am, may I ask a question?
Yes, go ahead.
Why does mercury form droplets while water spreads?
That's because cohesion in mercury is stronger than adhesion to glass. For water, adhesion to glass is stronger, so it spreads out. Surface tension. This is the tendency of a liquid to minimize its surface area. That's why water forms spherical droplets. Surface energy. It is the potential energy at the surface due to unbalanced molecular forces. Energy is absorbed when drops split and released when they combine. Angle of contact. This is the angle between the liquid surface and solid surface at their contact point. Less than 90 degree. Liquid wet surface. More than 90 degree. Liquid does not wet. Equal to 90 degree. Surface remains flat. Capillarity. Capillary action is the rise or fall of a liquid in a thin tube due to surface tension and adhesion. Formula: height equals 2 multiply T. Multiply cos theta divided by R multiply D multiply G.
Mom, may I ask one more question?
Yes, please.
Why does water rise in a capillary tube but mercury falls?
Excellent question. Water has stronger adhesive forces with the glass than cohesive forces, so it climbs up. In mercury, cohesive forces dominate, so it pulls itself downward and falls. Conclusion. Learning must continue with https://vishvasnya.org. Thank you for your engagement today. For any follow-up questions, clarification, and concerns, please feel free to get in touch with us. vishvasnya2025.gmail.com, office number 0956051573, WhatsApp number 0956051573. Jai Hind.